Mario, once again with MIA Microflight. Today is Thursday, January the 15th, 2026. And as I've been making these videos, repairing a lot of these helicopters that have been sitting on shelves for the past 20 some years, I I decided to, just to go full force and just start making all these videos as I am working on these, bringing these back into working order. So this is the MIA Robin 280 in an upgraded format. The Robin 280 is a helicopter that one of the first micro helicopters to be sold um, uh, by myself direct, to customers back in the late 90s, early 2000s. This is before any micro helicopters were on the market. I sold the Robin 280. Some people may recall the Robin 280. It had some issues, as any product that comes out to the market does. Typically when it's first released, when it's one of a kind. And so over the years, I've been making some modifications to the Robin 280. But basically, the Robin 280 used a similar setup, even though the frame was injection molded at that time. I modified that frame, and I went to a fiberglass CNC machined fiberglass frame with some of these other upgrades. My tough landing gear I employed on this one here. The original had a wire landing gear that was molded with some adapters that attached to the injection molded frame. So it was quite back in those years. We had to contend with the lack of the lack of the efficiency that we have in today's technology as far as power delivery is concerned. With batteries, lithium polymer batteries that are modern day components. Back in the day, we were using NiCats, the heavy NiCats and DC motors. We didn't have brushless motors back in those years just yet for hobby purposes. So this is once again the Robin 280 with some of those modifications and upgrades. And one of the key features here for this one, the way I designed this one, is with this offset flybar. It's very fluid, as I have mentioned that in some other short videos that I've done already on this one here. This one is going to be a long video, and just to capture this a little bit more. I can. My camera will help me here. My camera is not cooperating for some reason. There we go. Okay, so you can see this is all fiberglass. Plate CNC machine fiberglass plates with some creative ways of making this work, for the pivots and also for those linkages there. This all fiberglass, along with some CNC machined aluminum parts that were anodized in red. I had some of these parts, just both regular cylindrical rods, aluminum rods, as well as hex rods. I had a company anodize those for me in red. Some of those parts were anodized in red too, so that I can create my own JIS type screwdriver, such as this one. This is a 00 size. JIS is a spec, Japanese spec, as far as the tip is concerned. This is a very specific tip that works with little tiny screws that are employed on many of these little submicro helicopters. So I developed this for that purpose, because back in the day of the micro helicopter revolution, we're talking about 2000, 2005, nobody was really paying attention to something that, a tool that you could use with these little helicopters. I guess they expected that you had those tools, and many people didn't have those tools, including myself. So I had to source out the tips and create my own screwdrivers. The other thing with this one is that it fits in the hand, really comfortable. I added this rubber ring here just to allow me to grip this a little bit better, and so I can use that with a little more finesse. You have more precision with this type of screwdriver, and that's the reason why I created these, using some of these rods that I also employ in some of these mechanical assemblies. So that's where that comes from. This wash plate here, as you can see, it's got this ring around. This is my own original wash plate that I molded for the Robin 280 original. but I added this ring around to hold the swash plate more in place without having to use a ball for the universal joint that's typically done with swash plates. So that ring allows it to sit perfectly center, while you can also pivot this. This ring pivots on the roll axis, but it also pivots on the um, um, pitch axis via these connections here. There's a screw there. There's another screw there, but it's also in line with the ball there that's connected to the servos. So it's quite a nice, very very simple, if you will, setup. I mean, the squash plates are complex to begin with, but in simplicity, in the way I made this in line with this frame right here. This motor right here is not your typical the typical motor that I employ on the original Robin 280. The Robin 280 stands for 280, a 280 size motor. So these are 180 size motors, but I put it here because this helicopter is so lightweight to begin with that I can get away with this type of motor with the gearing that I'm using here. I'm using this is a 140 tooth gear, and that's a 10 tooth gear. So I'm using a 140 to 1 gear ratio with this particular motor, and that pinion that you see there. Makes for a very docile, very almost slow-flying helicopter, and very lightweight. And with this fluidity here on this rotor head, it's even better because it's very precise. When you want to go forward, it goes forward. When you want to go back, it goes back, sideways, etc. If this is somewhat limited in this smoothness, in functionality, you're going to have a helicopter that's a little bit hard to control. This is probably known to anybody that has worked with helicopters, radio control helicopters. If you're a diehard RC helicopter enthusiast, you already know those things, and you know what I'm talking about. That this holds truth, as far as the fluidity here. And I mean, I can blow on these things. This is so smooth. I did add these extensions here. It's a little bit weird the way. Excuse me, to set up, but I did do this on purpose just to see how much of an improvement in stability I can have with just this additional area here for this flybar. This flybar is a one-piece flybar fiberglass, as obviously shown in this video, and so I added these other pieces here just to give me a little more surface area. But eventually, I'm going to take that out and just go with the original one, the way I designed this. The screws here that you see here, these flybars, the way I designed them, they have perforations. You can see there they have 1, 2, 3 perforations, and that was to add a little bit of tip weight to the flybar to make it even more stable. So essentially, I don't need the surface here. I just need to have just a little more weight on the tips with 2 or 3 screws, and I could vary that from 1 to 2, 3 screws just to vary the weight on the tip of the flybar. So that was my solution to the typical wire type flybar with the independent paddles and those little collars, wheel collars that are used, to provide that exact same thing that I just explained with these metal screws. These helicopters, I have been making my own gyros. This is an electronic stabilizer for the tail rotor. It's a little bit different than your old-fashioned piezo type gyros that we used in the past. And so this is basically just a circuit board that you can buy, off the shelf. MPO 6050 stabilizer, accelerometer board, and if you marry that with a microprocessor, in this case I'm using an ATtiny 85, just a chip here. I'm not using the whole board. This is the DigiSpark boards, but this is just a direct chip here with some additional components there. The programming can be downloaded from there are a number of sketches that you can download, to stabilize, to make this into a stabilizing control system. I'm just using this strictly for the tail rotor. I'm not using this to stabilize the pitch or the roll. So it's the sketch or the program that is burned into the microprocessor is not that complex. I downloaded the original sketch, as I mentioned, some other videos from online, and but I did have to modify the sketch, so that it works better, with my particular setups, because not every setup is going to be the same. You have to tweak these things, and you have to be a little savvy with some of these Arduino sketches and Arduino software that allows you to do that, and how to input output these things to the microprocessor. So it does take a little bit of time. If you're technically inclined, it's not a big deal. Eventually you can find ways around that. So that's what I'm using for my gyro. This sits actually horizontally like this, because this is in the sketch. It's designed so that this measures senses the movement of the, in this case, the tail on the vertical Z axis. Now I could have designed this with I could have loaded the sketch with a change in that reference. Instead of the Z, I could have done it in the X or Y axis, so that this sits vertically like this on the side of the helicopter. So that's those are things that you can change in the sketch of the Arduino sketch, and before you burn it into the microprocessor. So, but this one is designed to sit horizontally like that, because I really I like the sitting flat like that, even though this should actually be directly underneath the rotor, to be perfectly, to be a little more precise, because this is, when this rotates, it senses it on the center of that sensor there. So the closer that is to the center of pivot point, the better it is, But typically, I just put them on the side here, and they work just fine for some of my other helicopters. So I'm using that. The tail rotor is electric. In this case, I'm using DC motors. I do have some of these with brushless motors, geared as well as direct drive. I have shown those in some other videos, short videos. So I've been making a lot of short videos, just for the sake of simplicity. It's just a lot easier to do a short video, but I am doing these as a supplement to those videos that I've been making in the short form. So check out my videos if you haven't done so. I have a lot of stuff that I've been doing lately with respect to helicopters. I have come full force, full circle to the helicopter hobby, radio control helicopter hobby. I mean, I started with helicopters back in the day. I actually started with rubber-powered helicopters, just making a lot of experiments to try to understand the functionality, mechanics, characteristics of the functionality of a helicopter. And so that's how I got started. I eventually sold a lot of kits, rubber-powered kits in various configurations. They were not just sticks, but more that looked like real helicopters. So I sold quite a bit of those through local hobby shops when I lived in Chicago, and I also sold those through Flying Model magazines, through an ad that I used to have there back in the day. Snail mail, as people say. I guess the snail mail is really slow, right? Because it's snail. Snails are slow in moving. But I have come, like I said, full circle back into what got me started here, because I'm also approaching. I'm also approaching I don't want to say the ends of my days. But I am much older than those years, and I think of all the stuff that I've done, the helicopters would be one of the focal points of my my work as far as MIA Microflight is concerned. So check out those videos. I hope this is interesting to some of you, and if it is, give me a thumbs up. It really empowers me to do a lot more, even though I don't totally rely on thumbs up or view count. I mean, I do what I do because I like doing these things and sharing with people. And if people are okay with that, I'm okay with that too. If they're not, that's okay too. I mean, we got to have a balance in life, and not everything is that important, and not everything requires 1,000 views, 1,000,000 views, people supporting you. So I am of that opinion, and I hope you are that way too.